Hi everyone, welcome back to the Sagar Tech Gates. In this video, we'll explore various procedural assignment statements, especially blocking and non-blocking assignments. If you attend any interview, especially in the design and verification, at least you will get 2 or 3 questions on blocking and non-blocking assignments. As a design and verification engineering, you should know the purpose of these blocking and non-blocking statement in detail. So in this video, we'll discuss all these blocking and non-blocking assignment with some suitable examples. Let's get started with the statements. So what is mean assignment? The assignment is the basic method of placing a values into the nets and a variable. Whereas in the Verilog, we have a two data type, especially in hardware connection point of view. One is a net, that is a void type, another is a variable type, that means a reg type. So placing a value onto these nets or variable is known as assignments. So in Verilog, we have a two main type of assignments are there. One is the continuous assignment, which assigns values to the net. So this continuous assignment used in the data flow modeling. So whereas another statement is the procedural assignments, so which assigns a values to a variable. So these procedural assignments are used in the behavior modeling style of Verilog. So see in this example, if you observe, so what is this? Assign some A XOR B. It is a continuous assignment statement. So assign carry is equal to A and B. This is a simple example of half adder. So these two statements are a continuous assignment statements. So it evaluates this right hand side expression. Whenever A or B changes, it evaluates that expression and assign to the left hand side this sum immediately. So that is known as a continuous assignment statements. So now whenever A or B changes, anything changes, it evaluates this expression immediately and also assign to the LHS. Okay, so now this is the continuous assignment statement. So now we see the procedural assignment statement. So now the statements which we written in the procedure block, like always are initial, known as the procedural statements. Now this q less than or equal to 0, q less than or equal to d, these are the procedural statements. Those are called non-blocking and blocking statements. So in this video, we'll discuss about these procedural assignments, especially blocking and non-blocking statements. So now we'll use this statement always in a procedure block like always and initial. There's a simple example where we use these a continuous assignment and a procedural assignments. So continuous assignment are used in the data flow modeling, whereas the procedural assignment are used in the procedure block like always and initial, especially in the behavioral modeling of Verilog. So now procedural assignment statements are used inside a procedure block like always or initial to assign a values to the variable. So now whereas in the continuous assignment statement, the LHS should be a net type. So that is a void type. We are assigning some values to the void type. Whereas in the procedural assignment statement, the LHS should be either reg or integer. So simply we can say it is a variable type. Already we discussed data types used in the Verilog. So that is a net type as well as a variable type. If not, please see that video, then you will get an idea what are the different data types are available. So procedural assignment statements are used inside the procedure block, that means always and initial, to assign a values to the variable, especially reg. These statements are placed within the procedure and each procedure adds its own activity flow. So now we are placing these statements in one procedure block. What is one procedure block? Already we discussed in the previous video. Okay, so it provides some activity. So each and every procedure has its own activity flow. So these assignment represent behavioral modeling where the designer specifies how the circuit should behave rather than just connecting the gates. Like in the gate level modeling, we'll use how many gates are there, how they are connected, okay, to design one simple digital system, to build a simple digital system. But in this case, just the designer focus on how circuit should behave instead of how many gates are there, how they are connected. Okay, so now in Verilog, we have two type of procedural assignment statements are there. One is the blocking assignment statement and another one is the non-blocking assignment statements. So in blocking assignment statements, we use to design a combinational logic. So if you want to design a combinational logic, so we'll prefer blocking statements only. Okay, so if you want to design a sequential logic, then we prefer non-blocking. Not prefer, we'll use to design sequential behavior, logic behavior, we use non-blocking. To combination logic behavior, we'll use blocking statement. So the left hand side of procedural assignment can take any one of the following, either range, integer, real time, or real data type. So what are all these? These are all called variables. So these are the variables in the Verilog data types. So now that left hand side should be a variable type only, whereas in the continuous assignment that should be a word type. Clear? So in Verilog we have a two procedural assignment statement. One is the blocking assignment, second one is the non-blocking assignment. These to design a combinational logic will use blocking, whereas the sequential logic design will use non-blocking assignment statement. And one thumb rule, so this good design practice, don't mix this blocking and non-blocking assignment in the same procedure block. We cannot write these blocking and non-blocking statements in the same procedure block, like in always or initial. So it's not good practice. So let's start with the blocking assignment. The blocking assignment statements are executed in the order they are specified in the procedure blocks. So a blocking assignment blocks the execution of the next statement. So this blocking assignment statement blocks the execution of next statement. So this blocking statement blocks the execution of next statement until the completion of the current assignment execution in a sequential block. Clear? Where this always initial or sequential block, the statement written in this always or initial are executed in which they are written. Okay, if we encounter a blocking statement, it blocks the execution of next statement until the completion of current assignment. Clear? So now a blocking assignment will not block the execution statement that flow in the parallel block. For example, I have two always blocks. So one blocking statement in one always block. Okay, never block the other statement in the another always block. So blocking statement will not block the execution of statement that follow in parallel block in another procedure block. It blocks only in that procedure block only. It blocks the next statement until completion of this current statement in that same block. So blocking assignment statements are assigned using assignment operator by using equivalent operator. So now see simple syntax, variable name, and expression. Clear? We see this example. So A is equal C plus D. What is the meaning here? So whenever C plus D, it evaluates this expression by reading the C and D value and assign to this A. Until this assignment, okay, it blocks the remaining statements written after this. Okay, it blocks the next statement until completion of current assignment. Assignment means it evaluates this expression and assign to this a variable A. Whenever it reads C and D values and it performs the addition and it assign to the variable E. After that only it execute, it goes to the next statement. Now see simple example here. Just I'll define one model for understanding this blocking assignment. So I'll declare two variable A comma B as an integer type and X comma Y as an int type. So actually we should declare the integer. In system Verilog we can use int as a data types, right? Anyway, we'll discuss about various data types used in a system Verilog also in the later videos. As of now, just assume that A comma B as an int type, X comma Y as an int type. So initial begin. As we know that initial will execute only one time, that too at 0 simulation time. Clear? Always will execute continuously based on the sensitivity list. Okay. So now initial begin. The statement written in the begin and end or the sequential statement execute one by one. Now see here A equal to 10. So what is this? This is a blocking statement. What is the syntax here? Variable name equal to expression. This is a one blocking statement. Always we write these procedural statement in the procedure blocks only, like initial and always. Remember, initial is not synthesizable. For understanding, I provide this example. So now A equal to 10, B equal to 15, right? Now here X is equal A plus B. What is the A value? Just whenever this statement encounter, then it read the value A and read the value B. A is the 10 and B is the 15. Then perform the addition, 10 plus 15, 25. Then assign to the 25 to the is X. Assign this result to the X. Now X becomes a 25. After assignment only, it goes to the next statement. Now here, y is equal a plus b plus x. What is the a value here? 10. B value is 15. So 25 plus 25, 50. Now the y is updated as a 50. Now just I want to display these x and y value, right? Now see, this is the output. So the value of x is 25, then value of y is 50. So here blocking assignment means it blocks the execution of next statement until the completion of current assignment execution. Now this statement blocks this statement until the completion of this statement. Completion means it evaluates this expression and assign to this x also. So like in a same C programming we use. Now next, coming to the non-blocking assignments. The non-blocking assignment allows scheduling of assignments without blocking the execution of statement that follow in a sequential block. So now I'll explain. So now it schedule the assignment. It evaluate the right hand side expression, but it won't assign immediately. I'll explain with some example, then you'll get an idea. So now see, the non-blocking assignment statements are assigned using non-blocking assignment operator less than or equal to. This is a non-blocking assignment operator, whereas the blocking assignment are equal. Now see, this is a syntax, same variable, less than or equal to expression. Now see, here a less than or equal to c plus d. So now we'll evaluate this expression immediately, but we are scheduling this assignment. We are not assigning to this a immediately. We'll discuss now. So now a non-blocking is a two-step process. If you want to execute this non-blocking statement, it has a two-step. Whereas in the blocking, immediately it evaluates the expression and assign to that variable in case of blocking statement. Whereas in the non-blocking, we should follow the two steps. The first step, the RHS expression is evaluated immediately. Whenever this statement encounter, the simulator will execute that RHS expression is evaluated immediately when the statement is encountered during the simulation. The RHS expression is evaluated immediately when the statement is encountered during the simulation. Then update the LHS at the end of the current time step. So now your assignment is happened only at the end of the current time step. Already we discussed what is mean current time step and precision. Okay, for example, tick time scale 1 nanosecond by 1 picosecond. What is the 1 nanosecond? There is a time step. For example, most of the time we'll write tick time scale. If you write, okay, type tick time scale 1 nanosecond by 1 picosecond. What is this nanosecond? This is called time step. Okay, so this updation is happened at the end of this time step. So if each and every nanosecond will update at the end of that nanosecond, then this assignment is happened. Okay, so a non-blocking assignment statements are executed last in the time step in which they are scheduled. That is, after all the blocking assignments in the time step are executed. So now you remember the thumb rule. So now the non-blocking assignment is happened at the end of the current time step after completion of all the blocking statement only. Now see, so this slide taken from the MIT. So now just I mentioned here reference. Now see, here blocking assignment, evaluation and assignments are immediate. For example, see in this example. So always at the rate A or B or C, begin and end. So now here it evaluates this expression A or B and assigning the result to the X immediately. After that only it goes to this expression, this statement. Here evaluate this AX or BX or C and assigning the result to the Y. Where in this case, evaluate this expression and then assign to the Z. Now, one by one it will execute. It blocks until completion of this statement. This statement blocks this statement until completion of this assignment. Right? So, whereas in non-blocking assignment, it all assignments differed until all right hand side have been evaluated. Nothing but the assignment is happened at the end of the current time step, but the evaluation is immediately. Now see here, AX or B, evaluate A and B, but defer assignment of X. We are not assigning this value to the X immediately. So now here evaluate this right hand expression. Here also we are evaluating the right hand side expression. At the end of the current time step, we are assigning these values to the x, y, z with their new values. So what is the meaning here? We are taking the old values of a, b, c. Then we are evaluate this expression. Then we are assigning to this x, y, z. So sometimes as above, the both produce the same result, sometimes not. Okay, these two statements will produce the same result, sometimes may not also. I'll tell you with some suitable example. So how we'll get different answer for the same statement, right? So now see, in this example, you remember this. Non-blocking is a two-step process. One is RHS expression is evaluated immediately when the statement is encountered during the simulation. And the next updated the LHS at the end of the current time step. Clear? Now see, this is a simple example. Module. There's some module name, swap example. So now if you want to swap two numbers, okay, in C programming or anyway, just use another intermediate variable, right? So now I declare integer a comma b as a one temp variable we want. So n shall begin a equal 10, b equal 20. Just I'm displaying before swapping. So what is the a, b value? So now what is the output? Before swapping, I get a equal 10, b equal 20. So it is a sequential statement. One by one will execute. First a equal 10 and b equal 20 executed, then display statement, then it display before swap a equal 10, b equal 20. After that, we'll use a temp variable. It store the value of a, then we'll store the value of b in a, and that b store the temp value. Just we are swapping by using one intermediate variable or third variable. Just I'm displaying after swap a equal 20, b equal 10. You know that this is a simple common sense. We use one intermediate variable to swap two numbers like in C programming. Say if you want to swap these two values, okay, in case of if you use a non-blocking statement, these two statements are enough. So what is that here? Same way here I'll write module name. I declared both variable a, b as an integer. Then initial begin, initially it execute first a equal 10, a is updated as a 10, b is updated as a 20. Just I display this statement before swap, a value is 10, b is 10. Now the swap using non-blocking assignment. Here I'll take a less than or equal to b. So what is the value of b here? B is the 20. Okay, it evaluate this expression. It read the value of b is a 20. It not assigned to the a. It will store in some intermediate variable. Assume that. Assume, right? It will store in some intermediate variable. So b is stored in intermediate variable. Okay. Same way, it won't block this statement. Here also we'll take the value of a. What is the value of a? A is the 10. Now at the end of this current time step, now here #1 means is the next time step. So in this time step only, all will execute in 0 simulation time only. Okay, this is a 0 time step, right? So this is a one time step. So now in this end of this time step, we are assigning this value of b to a and value of a equal to b. So what is the value of b now? B is 20 assigned to the a. Now what is the value of a? 10 assigned to the b. So b equal to 10. Even though we'll evaluate this expression immediately, but assignment is happened at the end of the current time step. Just I'll use one #1 delay, then I'm displaying those. I hope you understand. Now here, if in case of if you use the blocking statement, what happen? A will be, so B is 20, A means A also 20. Here A is 20, so B also 20. We'll get the same answer. But in case of non-blocking, it will take the old values. So b is the 20 and will store in some intermediate variable. A is the 10 will store in some intermediate variable. Then at the end of the current time step, will assign to this a and b. I hope you understand this example. So we'll discuss more example to understand, okay, this blocking and non-blocking statement. It's a very important as a design and verification engineering. You should know the in detail about this blocking and non-blocking. Without knowing, you can't write a code efficiently. Clear? Not efficiently, you'll get some other output. Okay. Now see this statement here, a simple example here. Module, some example, integer a comma b, initial begin a equal 10, b equal 20. Just I'm displaying these values before a, b. So now I'm giving this 2 time units delay. Now I'm displaying the value of a and b. Clear? Now see, assume that here another initial #1 equal to b, initial #1 b equal to a. So how many procedural blocks are there here? We have 3 blocks are there. As we discussed in the previous videos, so all processor blocks will execute concurrently. So all initial and always blocks will, that module contain n number of procedural blocks like an always and initial, all will execute concurrently. So now if we provide so 3 initial blocks, that module contains 3 initial blocks, all will execute concurrently. But for example, assume that this initial block will execute first, but we need to wait till here. What is the delay? H1, nothing but 1 time unit delay. We should wait 1 time step here. Clear? So here also we need to wait 1 time step. Then coming to the initial, there is no time delay, 0 simulation time only. Now it assigned A equal 10, B equal 20, then it display. Clear? A display. What is the output here? Before swap A equal to 10, B equal to 20. But here hash 2. Now we need to wait 2 time units delay. But this initial is only 1 time unit. So now we'll execute this. So it hold here, right? So it pass this. Then we go to this initial block. Now here executed hash 1. Assume that. So hash 1 1 time unit delay completed. Then assign A equal to B. What is the B value by that time? B is equal to 20. Assign to this A. Now what is the value? Now A equal to 20. At the same time, it is also hash 1. So after 1 unit delay, it is also updated. So what is the A? A is equal to how much value? By that time, A value is, assume that, so this executed first compared to this. So you mentioned both are execute concurrently. For example, if I say 2 numbers, you say 30 or 40. You cannot say 2 numbers at a time. Yes, sir, no. You should say first one number after another number. Same way, these 2 initial blocks will execute concurrently means one initial block will execute first and another. Clear? Now see, here A is equal to 20 and B is equal to 20. What is the output? After 2 time units delay, if I display those A and B values, both are 20. Same example, just if I change this order of these procedural blocks. Now here initial hash 1 equal to B. Right? Here I'll write initial hash 1 B equal to A. Instead of this, if I write B equal to A is first, after A equal to B. Just I'll change the order of this initial block. So we'll get a different output. Now see in this case, so assume that A equal 10, B equal 20, before swap A equal 10, B equal 20. Okay. Then display these 2 values A and B. So I need to wait 2 time units. By that time, this initial block will trigger because assume that 1 time unit delay completed. Now B equal to A. What is the A value? A is at 10. Now B equal to 10. After that, we'll execute this. What is the B value now? 10. Now assign to the A. No, A and B both are 10. So after 2 time units of delay, if we display these A and B value, both are 10. So what you observe from these 2 examples? So now even if we change order of this procedure block, we'll get a different output. It is not suggestible. Yes or no? All these initial blocks are parallel blocks, like they execute concurrently. Understood? If I change the order of these, means I'll get a different output. How do I know that? Okay. So now this is known as a race condition. Okay. If I change the order of this procedural block in our module, okay, that we'll get a different output. So this is known as the race condition. We need to avoid this. Okay. So same program, but if I change the order, then I'll get different outputs. It is not suggestible. We never write a code like this. So this is called a race condition. So you mentioned, sir, this initial block execute first after this. Who knows? We don't know. Okay. It depends upon the simulator implementation. Yes or no? It depends upon the simulator. Not depends upon our code. Sometimes we'll get the same 20-20 or maybe sometimes we'll get a 10-10. Just I'll take example. First initial block, this execute first and this later. Okay, I run this code in VCS, we'll get different outputs. Understood? So now this is known as a race condition. We need to avoid this race condition. While writing the program, keep in mind, okay, to avoid this. Because same program will give different output based on the simulator implementation. This is known as the race condition. Now see, in this example, same example I'll take, but what is the difference here? I'll take here, in earlier case, I'll take blocking statement. Whereas here, I'll take non-blocking statements. So everything is same, both. Okay, here I'll take non-blocking statement. Here also non-blocking statement. So I'll change the order of this procedure block, initial. Here this is the initial block. I'll write after this initial block. Here B less than or equal to first, A less than or B later. Here A less than or equal to B first and B less than or equal to A. Same, everything is same, right? If I display the output for both case, we'll get a same output. Before SAP 10-20, after SAP 20-10. Before SAP 10-20, after SAP 20-10. So now even though if we change the order of these procedural blocks in our model, we'll get the same output. So in that case, so we should use non-blocking statement instead of blocking statement. Because even change the order of this, we'll get the same output. Our intention is to swap the two numbers. Even if we change the order of these procedure block, we'll get the same output. Clear? That code should be independent on simulator tool. It independent on tool. Okay, one tool gives one output. Okay, same program, another tool gives another output, means it's not correct. Yes or no? Right? So now you should write a code. It is independent on other simulation tool. It gives the same output if you run in any simulation tool. Right? I hope you understand. So why here? Why? Now see, for example, I'll try to explain this concept, this program. First A equal 10, B equal 20. So now I'm displaying the values. Before SAP A equal 10 and B equal 20. Now I'll wait a 2 times delay. By that time, the initial is waiting. Okay, here 1 time delay completed. Clear? Now B less than or equal to A. What is the A here? A value how much? 10. So we read the value of A. You are evaluating this expression, means here we read the value of A. I said 20. We won't assign to the B immediately. We are assigning at the end of the current time step. So now till 0 simulation time, here now we are at the first time step. Yes or no? Now here, next, after evaluating, after reading, then we'll go to this. Yash1 means same current time step only. We are in at first current time step. Clear? Now we are reading the value of B. What is the B? 20. Now we are assigning these values to the B and A at the end of the current time step. Okay. So now after evaluating this expression, now A value is 10, B is the 20. Now we are assigning to this B and A at the end of the current time step, A is 10 assigned to the B and B is the 20 assigned to the A in the same order. Now that B become 10 and A become 20. Here also, even though if we change this order, it doesn't matter because we are reading and we are not assigning immediately. We are assigning at the end of the current time step. Okay, but in the previous case, now for example in the previous case here, so B, what is the B value? 20. We are assigning immediately to the A. Now by that time, what is the A value? A also 20. Okay, now we are here that A is not old value. This is a new value. A is at 20, not 10. By executing this initial statement, that A value is a 20 here. But in case of non-blocking statement, what is that? So now here A is 10. The B is not updated as a 10. Okay, clear? At the end of the current time step, now B is assigned to this, A is assigned to this B, and the B is updated as a 10. I hope you understand this example, right? Now there is no race condition here because irrespective of order, we'll get the same output, right? Now see, remember this, a non-blocking is a two-step process. One is RHS expression is evaluated immediately when this statement is encountered during the simulation. Whereas the second step is updated LHS at the end of the current time step. Clear? Now see this example. Now same example here. Module name integer a comma b, initial begin a equal 10, b equal 20. Just I will display those values a and b. So now a less than or equal to b and b less than or equal to a. So by that time, what is the value of b? B is the 20 and a value is the 10. So end of this current time step, we are assigned to this a and b. So b, nothing, 20 assigned to the 10, a value, so 10 assigned to this b value. Now if you display before swap a equal 10, b equal 20, then we'll wait 1 time minutes delay, 1 time step, right? Now after that, for example, if I write a tick time scale 1 nanosecond by 1 picosecond, what is the time step there is 1 nanosecond. So now it is in 0 time step. Now what is this? Now it is at 1 nanosecond time step. Clear? At 1 nanosecond time step. So by that time, we are displaying the values a equal 20, b equal 10. For example, same program, just see this. Now a same program, but I just didn't mention this delay. I didn't mention this delay. Same program, a equal 10, b equal 20. So before SAP, I'll execute a equal to b value, a value. So a is 10, b equal to 20. So now I SAP. So what is the value of b? B is 20. Okay, a value is 10. Now we read these values and we are assigning to this a and b. Yes or no? So now we are displaying that values. Now see, all at 0 simulation time only. All the statement will execute in 0 simulation time only. Yes or no? One after another, but all will complete in 0 simulation time only. So now display also executed in 0 simulation time. But here display is executing after 1 simulation time. Yes or no? Here we are specifying a 1 time unit delay. Here we didn't specify. So all will execute. So now see this output. Now see, before swap A equal 10, B equal 20. After swap A equal 10, B equal 20. Clear? So we didn't, okay, what you observed here, is it correct? Yes, it is correct. Because if you read the value at the end of the current time step, that A should be 20 and B should be 10 only. But why we got this output? Okay, the display statement will execute before assignment of this LHS. Okay, update the LHS at the end of the current time step. Before this display statement will execute. So assignment happened, the updation is only at the end of the current time step. But the display will execute before that. So before that, what is the value of A? 10, B equal 20. But if you read the end of the current time step, A should be 20, B should be 10 only. This is correct only. Okay. So we are using, okay, this display statement. It will execute before updation. Okay. So updation is happened at the end of the current time step, nothing but after all the statements. After the display statement, it will update it. So this gives a correct output only. If you read the A, B value, okay, at the end of the current time step or in the next time slot, we'll get correct value only. A is the 20, B is the 10. Understood? I hope you understand why you will get this, okay. Just we are displaying, okay, we are displaying the value, but updation is after this display only. That is the reason we get the same values here. I hope you understand. This is correct only, yes sir. But A should be 20, B should be 10 at the end of the current time step. Now, end of the current time step, then A equal to 20, B equal to 10. If you see after display, okay, this is the end of the current time step. This is a 0 simulation time. At the end, we'll get A equal 20, B equal 10. I hope you understand what is meant blocking and non-blocking statement. So I discuss with some suitable examples. So to model a sequential circuit, we always prefer a non-blocking statement. If you want to model a combinational circuit, we used blocking statement. So in next video, I'll discuss this blocking and non-blocking with more examples. So if you attend any interview like RTL design verification, at least you will get 2 or 3 questions on blocking and non-blocking statements. So understanding these statements are very important. Okay. Maybe you should write a code it independent on a simulator implementation. So same Verilog code, if you run on a different simulator, you will get different output. You should avoid that, okay, race conditions. So for that, you should understand in detail about this blocking and non-blocking statements. Actually, why we need this non-blocking statement, okay, why we need this blocking statement in Verilog. Clear? For example, if you take a non-blocking statement, it take the old value, not updated value. Whereas in the blocking statement, we will take updated value. So this is most suitable for combination. Whereas that this take the old value means it's for a sequential circuit. If I have a flop, whenever if you get the clock passage, it will take the old value, not a new value. So to model that type of circuit, we always prefer a non-blocking statement. Thank you very much.